Hello class 12th. In the last and third part of this chapter, refraction through prism. In this session we will discuss about the formation of rainbow, second the scattering, and if possible means not possible means and some numerical problems. So let's see and get started. So today's first topic is rainbow. You might seen in the rainbow in the sky when it forms just after the rain. If you just have noticed this, the rainbow used to form just after rainbow. Why it is? And one more condition, if the sun is behind you, the important thing is the sun is behind you and the rain is just after the just rain. Suppose the cloud has moved just after there and the sun is behind me. Sun is shining brightly. At that time, the sun ray will fall on the raindrop and the raindrop will act as a prism. How? Just see this diagram. In this diagram, the white light falls on the prism. Then this light is splits into its constituent colors. This is what? The dispersion. What is the object here? Prism. But can you imagine this? This prism is just behaving like a raindrop. See? The shape is like that. Same way, when it rains, just after means if the cloud has moved a little bit ahead you and the sun is behind you, so that raindrops are behaving like a tiny prism, and the tiny prism makes same dispersion in the sky. That is why you are seeing the sky. For example, see, this sun is behind me. This sun, and the light falls on the raindrops which is falling from the cloud. And due to this raindrops which is falling, when the light falls on this raindrop, so see, dispersion is going on. This dispersion in the sky shows you what? The rainbow. What is the condition? Sun must be behind you and the rain after the just rain means the cloud must go ahead to you and then you will see the rainbow in the sky. Now the question is, if you are able to see these colors, means this spectrum in the sky, why not every time? Because there is not raining every time in front of you and the sun is behind you. So this is clear. And the second question is, the color of sky means if the 7 colors are visible due to this prism, this tiny prism, the raindrops behaving like a tiny prism. So why the sky has blue color? So if somebody is answering that this is because of the color of sea, the reflection of color of sea, so you are absolutely incorrect. Due to the color of sky which is blue, the sea water has blue color. Why the sky has blue color? I will explain further. Just wait for time. Here we are discussing about the rainbow. Now this rainbow is about 2 types. One is called primary rainbow, second is called secondary rainbow. You might have everyone have seen the primary rainbow, but very rare there is secondary rainbow. How the secondary rainbow looks like? The difference of the primary and secondary, first of all, without knowing anything first of all, is that in primary rainbow, whatever the order that you are seeing from red to violet, but in secondary rainbow, you will see from violet to red. The order of color is reversed. Second difference is the primary rainbow will be little bit brighter and the secondary rainbow will be little bit fainter, means that will be dark, this will be in the light color. And the primary rainbow receives, suppose the light is coming from here, from the sun. I am the observer and I am watching the sun means rainbow. So I will see, when I will see this rainbow, so at my eye, the red color will subtend 43 degree and violet color will subtend 41 degree. Means it's all about 41 degree to 43 degree, all the spectrums. And secondary rainbow, and one more thing, in primary rainbow light suffers in raindrop 2 refraction and 1 total internal reflection. Remember and listen clear. In primary rainbow, the light suffers two refractions and one reflection. While in secondary rainbow, as a primary rainbow, the range of angle is from 41 degree to 43 degree. But in secondary rainbow, which is very rare to see, in secondary rainbow, the red to violet, it varies from 51 degree to 54 degree. But order will be reversed. How the secondary rainbow look like? First see in this diagram. In this diagram you can say the upper one is primary, order from red to violet, and the lower one is secondary rainbow, order from violet to red. This secondary rainbow is little bit rare. I have captured one image by my own phone once it was forming in the sky, secondary rainbow. Just see, this was captured by my phone. The primary and secondary, I don't think you are able to see this secondary rainbow. So this is the formation of secondary rainbow. And in secondary formation, in the secondary rainbow formation, two refraction and two total internal reflections are there. How to see and how to again to differentiate in examination, it used to come to differentiate about the primary and secondary. How you will differentiate? First point, the primary rainbow starts from red to violet, while secondary has reverse order from violet to red. Second difference, the primary has the angle range from 41 to 43, while secondary has the angle range from 51 to 54. Third difference is the primary suffers two refraction and one reflection, total internal reflection, while the secondary rainbow suffers two refraction and two total internal reflections. This is all about the rainbow. Just see the diagram if you want to say the primary and secondary rainbows reflection. See, the upper one diagram is for primary formation. You can see here there is two refractions and one total internal reflection. Before entering in the drop, the light refracts, then it comes to the end of the drop, it suffers total internal reflection and then returns. Then again the light coming from drops to air, so it again refraction. So two refraction, one total internal reflection. While in the secondary rainbow, see the second drop, here the light enters from bottom of the drop, then it refraction, then total internal reflection, again total internal reflection, and then again refraction, then it comes down. So you can see in primary the light goes from top and then comes from the bottom, but in secondary formation means here the light goes from bottom and comes from the top. So that is why in the primary, whatever the formation, whatever the spectrum you will see, in the secondary you will see the reverse spectrum. This was all about the primary and secondary rainbow. Now our next topic is scattering of light. What is scattering? First listen. If any light ray while traveling in air or any medium, if it strikes with some particle, the conditions are the wavelength of light must be less than the diameter of the particle. How? See here. This is suppose a wavelength and that is a particle. Here the wavelength of light, suppose it is x, and the diameter there, suppose it is d. If the d is greater than x, means the diameter of particle is greater than the wavelength of light. If it happens, then the light will absorb by the particle. Then what will happen? The light will absorb by the particle and then particle will re-emit the light in all possible directions. This is actually the scattering. Again listen, how it can be maximum scattering. As I said, the diameter must be greater. So the tiny particles in the sky has very smaller diameter. So to happen this phenomena, the size of the wavelength should be smaller than that. So you can imagine how small the wavelengths are. So if this smaller wavelength, the very small wavelength, is absorbed by the particle and it re-emitted, making the little longer wavelength and scattered in all directions, all possible directions. So what is the phenomenon? The absorption of light by any particle. Condition is the diameter should be more than wavelength. So when it absorbed by the particle re-emit in all possible directions that light, little bit longer wavelength. Then this phenomenon is called scattering. This was studied by the scientist named Relay. That is why the equation is given by the Relay. That Relay criteria is which is known as the Relay criteria for scattering. So again I'm explaining what Relay said, that if a smaller wavelength light falls on any particle, that is absorbed if the diameter of the particle is more than the wavelength of light. So it re-emits in all possible directions with longer wavelength than the incident wavelength, and the intensity of the scattered light, is inversely proportional to the fourth power of the wavelength of the light which was incident. So it means as small the wavelength will be, as scattering will be more and more. So how to see scattering relay law? This is called relay scattering law. This is called relay scattering law, and that is scattering is inversely proportional to the fourth power of the wavelength. Because of this scattering, you are able to see the blue color in the sky. But how it happens? Just listen again. Suppose in the sky, the white light is coming from the sun, okay? And now there is atmosphere. In the atmosphere, the dust particle will be there. So that dust particle will receive these rays. What will happen? There are from red to violet. So smallest wavelength is of violet. So the violet will be absorbed by first of all by any particle, and that will be re-emitted, and it will re-emit in all the atmosphere. So the color of atmosphere will be violet. But after that, little bit more longer wavelength, but the dust particle also increasing their size. Then after the violet, indigo spreads, so the sky looks like indigo. Then after blue color scatter, then the sky looks blue. And after that, the scattering of other lights, as I said, if wavelength increases, so intensity of these the intensity of scattered light will decrease. So that is why the intense light of blue color in the sky is visible. But due to this color, sky color, blue, the sea water is also looked blue. Now, another situations like sunset and sunrise time, the same phenomena is happening. During sunset and during sunrise, the light passes through the maximum length of the atmosphere. So maximum scattering. So after violet, indigo, blue, all the colors is scattering. The last color is red. So red color overrides all the other colors. That is why the sky looks red. But in that section where the scattering is maximum, because of the red color. The red color is used as a danger signal. Why? Because red has highest wavelength, least scattering. If it will have least scattering, so it will travel to the longer distance. That is why danger signal can be seen from a longer distance. Ambulance written on the ambulance car in red color, and many more examples are there in the book. Just go through that, see the examples. If you are facing any problem, any doubt, inform me, I will resolve that. So now we are moving to our numerical section. Let's see. So in the numerical section, chapter 16, question number 2, on demand of Samir Singh. A biconvex lens made of glass whose refractive index is this, and radii means both radii of curvature respectively 20 cm and 30 cm. Calculate its focal length. So let's write first given value. Using this equation, fill the values. So on solving this, 1 upon f is equal to 1 upon 24, or f is equal to 24 centimeter. Why centimeter? Because radii of curvatures are in centimeter, so the focal length will also be in centimeter. Now again same chapter, but question number 4. The question is, an empty spherical flask of diameter 100 centimeter is placed in water of refractive index 4/3. A parallel beam of light strikes the flask. Where will it appear to come from to an observer within the flask? So first draw the diagram. According to question, consider this is a flask, because in question it is written spherical. This spherical flask is now placed in water. So as the question says, a parallel beam of light, so this is parallel beam, and the diameter of this spherical flask is 100, so radius of curvature will be 50 centimeter. So for this light ray, this surface is convex, moving from denser medium to rarer medium. This is empty, means considering air. So this refractive index I'm considering as 4/3 and it's as 1. Using this equation, let's fill the values. So value of refractive index 4/3, value of V. Object is the light ray is coming parallel, so it means object is at infinity, and the remaining the 50 centimeter radius of curvature. Let's solve it. Thereupon 4/3V minus 0 is equal to 4/3 minus 1 is 1/3 into 50. Thereafter 4/3 is cancelled. 4/V is equal to 1/50, or V is equal to 200 centimeter. So let's draw this first, how it look like. So this was about to the position of image, because we are considering that there is no second surface. The straight is going here, and the distance from this point as a pole from here to here, it is 200, because question it is V is equal to 200. So from here you can say here to here 200 centimeter to here, and this is of 100. So now what will be the from here to here? 100 centimeter. As I said, the image formed by first surface will act as an object for the second surface, and second surface starts from here. So this 100 centimeter will be object distance for this surface. Let's do that. Now the medium is reversing, means from water to air, now air to water. So refractive index was in, currently we will write 1 upon n by V minus 1 upon U, and so on. The value of U will be 100 centimeter. The image formed by first will act as an object for the second. Let's fill the value and see. See right now here, the reciprocal of refractive index means, as I said, light coming from air to water, currently here water to air, and now air to water. So it is just reciprocal, like a principle of reversibility. So here it is, when it was going from water to air 4/3, now it is air to water 3/4. Value of U 1 upon 100, 1 upon n 3/4 minus 1, and minus 50, because the radius of curvature for this surface will be negative. So here it comes. Let's solve it further. So see here, 3/4 minus 1 will give minus 1/4, and minus 50, because radius of curvature was negative. So minus 50, this negative will be cancelled. Let's do further. So see here, 3/4V as it is, minus 100 as it is. 1/4 multiplied with 50, 1 upon 50 becomes 1 upon 200. Taking 1 upon 100 on the other side and take LCM, see what happens. So this 3 will be cancelled, and 4 divided by 200 divided by 4 will give 50. So on solving this, V is equal to what comes? 50 centimeter. 50 centimeter means, see the diagram first. So 50 centimeter means from here to 50 centimeter will be half somewhere here. So this is 50, this is final position of image, here it will come final position, this is 50. The question was where will it appear to form? So where it will appear? From here 100 and plus 50. Where it is appearing from the surface? 100 plus 50 at 150 centimeter. This is the correct answer, 150. See the next question, chapter 16 again, question number 6. A point object is 2 centimeter below the concave meniscus of water, refractive index 4/3, of radius of curvature 0.5 centimeter. Locate the image. First I'm drawing the diagram to understand it. So see this, a concave meniscus. Suppose this is water, this complete water, and inside water this is the object 2 centimeter below the meniscus. The meniscus is concave. It doesn't mean in front of concave. The meniscus is concave. We know that water forms concave meniscus, and under that concave meniscus 2 centimeter below, what is there? Object O. And after that the radius of curvature given, that is 0.5. If you will see like this, so you can say this is convex surface, not like this. See like this. See, then you will say that the light is starting from the object, so this is like convex surface. So we know the equation for this. Let's solve that. So these are the given values. Value of U 2 centimeter, R 0.5, radius of curvature, and the refractive index 4/3. But see, the light is going from water to air, not air to water. So here N2 is air, N1 is water. Remember, N1 water, N2 air. Okay, I'm writing here the equation. We know that the equation N2 by V minus N1 by U is equal to N2 minus N1 by R. You can also write N instead of N2 N1, only N. So what will be the N? The reverse of this, because light is going from water to air. So to either use reverse of this value, means reciprocal, or like this. Let's fill the value. Now see here again, N2 I said from water to air the light is going. So N2 will be air, N1 water. Value of V we have to find, value of U is given, N2 minus N1 as it is, and negative, because if you can see for the convex surface the light is going from here to here, so this is in right direction, so negative value. Hence this is, let's solve this. Taking this value on that side, on solving this, on taking LCM of this value, this will become, thereafter 1 by V is equal to 8/6, or V is equal to 0.75 centimeter. So this way we have solved the question. See again, same chapter, question 18, requested by Nitin Gupta. The question is, the radii of curvature of convex lens 1.5 refractive index given are in ratio, given in ratio 1:2. This is radii of curvature. This lens renders means forms image coming from filament at distance 6 centimeter. Renders means focuses, or you can say forms image. So at 6 centimeter the image is formed, and the rays are coming from filament parallel, means object is coming, the rays are coming parallel, means object is at infinity. Calculate radii of curvature. So I'm writing first the given values. Here it is the given, refractive index 1.5, as the radii of curvature in ratio 1:2. I'm taking R1 as R and R2 2R, U infinity because the rays are coming parallel. Value of V is 6 centimeter. Let's write the lens maker equation. This is our lens maker equation. Since the lens is convexo-convex, or you can say double convex, so the R2 will be negative, so this equation will become positive here. And further see here, I'm filling the value, but before filling the value, we also know that 1 upon F is equal to 1 upon V minus 1 upon U. I'm just writing here, instead of 1 upon F, what we can write, 1 upon V minus 1 upon U is equal to N minus 1, 1 upon R1 plus 1 upon R2. If you remember this, this was this was there in the equation while proving this equation, lens maker. So on putting the value here now. So let's see, 1 upon V, value given, U refractive index, and the value of R1 and R2. So after this, 1 upon infinity is 0, 1 upon 6, 0.5, 3/2R. On taking LCM, it will come 3/2R. On transposing the R to this side and 6 to that side, so 0.5, 3 and 6 comes here, remaining 2. So 2 3s are 6, so 3 3 is 9. 9 into 0.5 comes to 4.5. So R comes to 4.5. What was R? R was R1. So we can say here R1 is equal to, we have calculated 4.5 centimeter. Second is R2. R2 was 2R. So write R2. R2 is equal to 2R, or you can say 2 into 4.5, or simply R2 is equal to 9 centimeter. So this is R2 and this is where? This one. R1. Done. Now I'm ending this session. So if you're facing any problem, any numerical problem, inform me in the comments. I will solve your problem. Till then, be safe, take care.